talk about? That makes me happy. Let me see some notes. X cubed. What rule have I followed? What overall type of problem is this? Power rules. What's the derivative? Okay, the rules, you bring the 3 down, you leave this alone, and that makes it 2. Yes?
Yeah.
All right. And what's this? What's that rule? It's still power rule, or that's a 1. You bring it down. Constant rule. Great. You guys are owning this stuff. So then you guys have no problem doing that then. What? What's happening? We did this. And you did this.
Can you bring down that 12 squared?
So what is it, right? Like you say, start taking derivatives whenever we feel like it. What happens? Well, what if I did this, and this is just kind of one thing, you know what I'm saying? Like I could follow this just like this one, you know what I'm saying? Well, why don't I do that? Why don't I call u equal to 4x plus 1? Then y would equal u cubed. Okay? Now, instead of doing dy dx, or taking the derivative like that, what if I said, because I don't have a y here, do you see that? But could I do du dx? Take the derivatives of this u function in terms of x. Wouldn't we then follow the same rules? We want to take the derivative of the u function in terms of x. So that's the x that we usually do. So what's this derivative? 4. And then I don't have any x's over here, but I have a y function in terms of u. So could I say, take the derivative of the y function in terms of u, and then follow those same rules? Like pretend that this was an x, and just follow, instead of dy dx, dy du, and follow the same rules. Would that work? Yeah. So then what is dy du equal to? 3u squared. Does that make sense, you guys? Well, what I want to know what dy dx is. I want to know what the derivative y is in terms of dx. Well, I don't have either of these. I have a dy du, which doesn't help me, and I have a du dx. And don't forget what these dy's and dx's are. Going back to the beginning, remember they were change in y over change in x. They're numbers. Do you know what I'm saying, Michelle? A dy is a number. A dx is a number, really, but it's a really, really small number. You know what I'm saying, Eric? We started out all these derivatives. The whole thing was change in y over change in x. That dy over dx for really small values. So that if you did multiply these two together, like I heard, what would technically happen? Yeah, if you multiplied these across, two fractions, you multiply across, you would get dy times du divided by, I'm going to flip these, dx times du. You have this fraction all under 1, and you have the same number on the top and the bottom. Bam! So that these are equal. Does that make sense, you guys? So let's try this one here. If I wanted dy dx, would be the same in this case as the dy du times du dx. Well, in that case, dy du is equal to 3u squared. Du dx is equal to 4. Well, this doesn't help me, you know what I'm saying? But what was u equal to? So I can resubstitute back in. Now you have a dy dx back in terms of x. And if I just multiply these two together, if I want, I would get 12 times 4x plus 1 squared. And here's what I want you to do. Let's graph 4x plus 1 cubed. Take a look at it. Take a look at the graph. Maybe a little, check your table, maybe up a little high. You might have to change your window. Oh, you see it? You see it right there? It's a little skinny thing. Do you guys see it there? If you do a zoom, is that a zoom 6? You'll have a skinny little thing shooting up. Do you see it? Okay, do your second calculate dy dx. Add x equals 1. What is the derivative? Add an x value of 1. And if you ever have to do that, ask the person next to you. What is, for this function, 4x plus 1 cubed? Everyone grab this one. 4x plus 1 cubed. I'm going to graph the original function, and I want to find the derivative value at 1. Jessica?
You want to know the derivative?
Yes.
300.00006.
So 300, pretty much. It's just with a little, looks like there's a little rounding error there. So add x equals 1. We got f prime, or y prime at 1 is equal to 300. Okay? Well, does our equation work? If this is my dy dx function, let's plug it in. At 1, this will equal 12 times 4 times 1 plus 1 squared. What is that equal to? This is 4, 5 squared is 25 times 12. We did it correctly. You just correctly took the derivative of this double whammo function. But I don't know how to do this all at one time. So what I did was I separated it into two pieces that I could take the derivative of. And then I took the derivative in terms of each and multiplied them together to get dy dx, which is what I wanted. Does that make sense, you guys? Let's do another one. Let's do another one that we can check. And this one will be easy to check. Let's do x squared cubed. Now, I know how to take the derivative of this, well, if I multiply out my exponents. Exponents raised to exponents, what's the rule? Multiplying. So x squared cubed is the same as what? Okay, so over the side I'm just going to write x to the 6th. And then what's the derivative of this?
6x.
Yeah, okay? So this should be what I get, but I'm going to try this new rule. Okay, wait a minute, just to see, just to trust that it works. Okay? Alright. So, again, here's something and then it's raised to another power. So what do you want to call u equal to? It's kind of like two things together. Yeah, let's call u equal to x squared. So then y equals what? U cubed. What is du dx then? The derivative of u in terms of x is what? 2x. What is dy du equal to then? 3u squared.